Hello, and welcome to the 6th video in our series on scientific writing. In the previous video, we started fleshing out the first part of the action, that is, the methods or theory section. In this video, we will look at the results part of the action. But before we get started, let's revisit the challenge I gave you in the previous video. What is the scientific course logo supposed to represent? To those of you who said a Feynman diagram, you are correct. To those of you who said crocodile, maybe less so, but I'm open to interpretations. Now remember that in the action, you describe the work that you did by answering the question, what did you do to address the challenge? But just as important is the answer to the question, what were your findings? The answers to this question should be found in the results section of the action. And that's what we will discuss today. And just to remind you, you don't actually have to use the section headings methods, theory, or results. You can use something more descriptive if you like. What's important is that the first part focuses on what you did, while the second part focuses on what came of it. When writing the results section, it is important to realize that you don't need to include every single result that you came up with. Don't just dump the results into the action. Remember that you are telling a story, and when it comes to story, sometimes less is more. We often get many results along the way, not all of which are needed to tell the story. You'll need to decide which of your results are worthy to go into the paper and which results should be tossed out. You'll need to decide which results to condense and which to eliminate. And deciding is difficult, both intellectually and emotionally. Deleting results from your work hurts. So to help you decide, it's worthwhile keeping the following questions in mind. Does the result answer the questions you posed in the challenge? And does the result add support to your conclusions? If not, then it will likely distract and confuse, and you should get rid of it. Now, this doesn't mean hide results that contradict your conclusions. Your conclusions are, after all, based on your results. It's just that, after some point, additional results don't strengthen your case. Okay, so now it's your turn to do an exercise. In this exercise, I would like you to make a list of your results, or anticipated results. These could include results of derivation, results of simulation, plot of results, a proof or conjecture. And then once you've made your list, for each result, answer the following questions. Do the results answer the questions you posed in the challenge? And do the results add support to your conclusions? Now is a good time to pause the video to work on the exercise and try not to spend more than 10 minutes on it. Okay, I hope you've had a chance to work on the exercise. Another thing to think about is how you should present the results. To aid understanding, you need to give more than the raw results. You need to provide a framework, because without a framework, readers struggle with the details. And because of this, most results call for an LD structure for each result. So what you should do is frame major points or patterns, then flesh out the details. Don't present details and then frame them. And certainly don't present details without framing them at all. So let's look at this in the context of figures, which are one way of presenting results. Imagine I'm reading a paper and I get to a point where it says, Figure 4 shows the collective decay rates for an N1 by N2 by N3 equals 2 by 3 by 4 system. Then I look at the figure and, okay, sure, I can see the collective decay rates. There's some interesting colored squares, but what do they mean? There's some cryptic 1D SR, 2D SR. I wonder what's going on here. This is a bad example of how you should present your results. A better example is to follow that with an explanation. We can see that the decay rates are segregated according to the number of directions into which the qubit radiates. This is in contrast to what we see for a one-dimensional system. So that's okay, it's a little bit better, but the problem is that as you're reading this paper, the text refers to figure 4. So as soon as you see figure 4 shows and finish reading that sentence, your eyes are going to jump to the figure, and then you'll be confused, and who knows how long you'll try to spend to decipher the figure. Then after you're already frustrated, you come back to the text and realize, oh, that's right, they've explained it. But now after explaining it, you're going to have to go back to the figure again. So a better way to do it is as follows. We want to frame the results first. So we're reading the paper and we get to the point that says, we find that in a d-dimensional quantum network, the superradiant states emerge differently than for a one-dimensional case. Specifically, the superradiant states segregate according to the number of directions into which the qubit radiates. Well, that sounds really interesting. I wonder what the supporting evidence is for that. The next line says, this segregation of the superradiant behavior is illustrated for a small network in figure 4. Now I look at the figure and I can see that the different colored squares must refer to the segregation. And the text already told me that there's something significant about the number of directions into which the qubit radiates. So I can already take a pretty good guess at what these labels 1DSR, 2DSR, 3DSR mean. They refer to superradiance into different dimensions. And then I don't even have to read the full figure caption at this point. I can already see in my peripheral vision that what's being plotted is the collective decay rates. Now we just looked at an example of framing the results for figures. But this also holds for other kinds of results, such as tables, results of derivations, results of simulations, proofs, and conjectures. Anything that supports some kind of interpretation should be written in an LD structure, where the lead frames what you have learned from the results, and the development gives the results as evidence. Okay, so now it's your turn to do another exercise. I'd like you to flesh out the answers to the question, what were your findings, into the lead of each subsection. In doing so, you will start writing the results section. And remember that you should frame major points or patterns, then flesh out the details. Don't present details and then frame them, and definitely don't present details without framing them at all. Now is a good time to pause the video and try not to spend more than 10 minutes on this exercise. Okay, so I hope you've had a chance to work on the exercise, and now let's just summarize what we've learned in this video. You shouldn't dump all of your results into the action. When deciding what to keep, ask yourself, does the result answer the questions you posed in the challenge? And does the result add support to your conclusions? And to aid understanding, you need to provide a framework, because without a framework, readers struggle with the details. And because of this, most results call for an LD structure for each result. And now it's time for you to do some more homework. Now that you have written the lead parts of your results section, it's time to write the development parts. The development parts flesh out the details. Remember, don't be scared. Your writing doesn't have to sound great just yet. We just want to make sure we have all of the content and that it is roughly in the right place. As I keep reminding you, we will edit everything later to make it sound beautiful. In the next video, we will look at writing the resolution. See you next time!